Hi dear students, welcome back to our channel N. Vinay Kumar Basics of Physics. Dear students, in our channel I am uploading all the videos from 9th class to intermediate second year physics, and along with those videos I am also uploading all the MSET topics and polytechnic syllabus also I am uploading. That's why you have to follow my channel regularly. Come to the point. In this video we are going to discuss about the one of the important problem that should be belongs to the intermediate secondary physics, especially in the chapter of current electricity, and this type of questions will be asked in the competitive exams also. Okay, without late we are going to the topic. So dear students, if you want to understand the content up to completely, then you have to watch the video up to and without any skip. Okay, let's go for the topic. The problem is on the board. Let's go for the problem. Two lamps, one rated 100 watts and 220 watts, and the other 60 watts at 220 volts are connected in parallel to a 220 volt supply. What current is drawn from the supply line? Two lamps, one rated means here nothing but this power. Rated is how much? 100 watts, and voltage is what? 220 volts, and the other bulb 60 watts and 220 volts are connected in parallel to the 220 volts supply. Clear? What current is drawn from the supply? So children, what you are saying, there are two lamps. So this is nothing but a bulb like this, anything, whatever may be. So it is the bulb that is having how much power? P1 is how much? 100 watts, and its voltage is what? 220 volts. And there is another bulb. This is the second bulb. So first terminal, first, second. So they should be joined like this. Now it is parallel combination. Clear children? So this is the second bulb that is having some power. How much? He was given 60 watts. How much? 60 watts, and voltage what? 220 volts. So this is P2 and this is nothing but V2. Now again these are connected in parallel to a battery of 220 volts. Then what current is drawn from the supply lane? Then how much current is in the circuit or the particular line? That is the question. So here you have to understand. Now these two are how these two are connected? As in parallel. That's why here there is some power is there, voltage is there. In the same manner, some resistance also there. The resistance of the first bulb is R1 and resistance of the second bulb is R2. How these are? These are two are how these two are? R1 and two bulbs. R1 is what? Resistance of the first bulb. R2 is what? Resistance of the second bulb. How these are connected? Are in parallel. What it is? In parallel. That's why here two bulbs are in parallel means their resistance also in parallel. That's why their combination is in parallel. That's why the effective resistance is Rp. Clear? And now the amount of current in the current is what is? Circuit is I, and resistance is what? Rp. And how much voltage is given? 220 volts. How we can find out the current? I is equals to what we know, Ohm's law. V is equals to IR, and I means what? V by R. So here R is nothing but Rp. Clear? How much current is taken from the line? So I is equals to V by Rp. Here V value is 220 volts, and now we have to find out the Rp. So this is simply about the what is the problem given. Two bulbs are there, they are connected in parallel, and again they are connected in parallel to the battery of voltage 220 volts. Now how we can find out the parallel combination of these two? We don't know about the R1 value, R2 value. Then how we can find out? So simply by using these values we have to find out it. So I think you have idea about the definition of power. What is power? Is rate of doing work. Rate of doing work, what we call power. P is equals to W by T. P is equals to W by T, children. So already what we know, V is equals to W by Q. W is what? VQ. W is equals to what? VQ. And P is equals to VQ by T. And again P is equals to V into Q by T. Rate of charge is what we call current. P is equals to VI. And what is V? V is equals to IR. Then what do you get? P is equals to IR into I. That is what? I square R. P is equals to what? I square R. So from that, what right? We are going to write here P is equals to I square into R by R. Then what do you get? P is equals to I square R square by R. That is what? V square by R. So now we are going to use this formula. P is equals to V square by R. We have to use this formula. Clear? What do you have? P is equals to V square by formula. We are going to use. So already P value is given. V value also given. Then we can easily find out the R value. So that's why here first we have to write the given values and the formulas we are going to take like that. Simply forget about all these things. Simply have to remember what is the relation between here P and V and R is P is equals to V square by R. So children, very simple. Here what write? P is equals to V square by R. From that what write? R is equals to what write? V square by P. R is equals to what? V square by P. From that formula we are going to write R1 is equals to V1 square by P or P1, and R2 is equals to V2 square by P2. So by taking the values, what is V1 value? 220. 220 whole square by what is V1? 100. And what is R2 value? V square by P2 or V2 square by P2. What is V2 square value? 220. So 220 whole square by P2 value is what? 60 watts. So now we have to go for the parallel combination of these two. What is the parallel combination formula? 1 by Rp is equals to 1 by R1 plus 1 by R2. Then what write? 1 by Rp is equals to simply we can directly write this one. Rp is equals to what? R1 R2 by R1 plus R2. This is the formula we are going to use. So children, so we need some space, that's why I am erasing this one. Now we have to substitute the values of R1, R2 in this formula. Then what do you get, children? Rp is equals to R1 into R2. What is R1? What is R1? 220 whole square by 100 into R2 value is what? 220 whole square by 60 by 1 by R1 plus R2. So R1 is what? Yes, again same 220 whole square by 100 plus 220 whole square by 60. So children, here we will write Rp is equals to here 220 whole square into 220 whole square by 100 into 60 by, in denominator which is common? 220 is common. Then 220 whole square you will take common. Then what we get? 1 by 100 plus 1 by 60. Then what you get, children? Here same thing, 220 whole square into 220 whole square by 220 whole square of LCM. What it is? 60 plus 100 by 60 into 100. Clear, children? Here 220 whole square, 20 whole square cancel. Then what you get here? Rp is equals to 220 whole square by here what do you know, by this already 100 into 60 is there. Here 100 into 60 by here 60 plus 100 160 by 100 into 60. These two are cancelled. Then what you get? Rp is equals to 220 whole square by 160. So I'm writing here Rp is equals to 220 into 220 by 160. 160. Here 0 0 cancel, 2 8s are 2 11s are. Clear? Next thing is what? 2 4s are 2 1 1 0 are. Then what do you get? 1 2 1 0 by 4. 1 2 1 0 by 4 you get. So this is the Rp value. Clear? And next thing is here what you have to find out current value. What did I told you already? Current value is what? I is equals to V by Rp. What it is? I is equals to V is what? 220 volts by Rp value is what? 1210 by 4. Then here I is equals to 220 into 4 by 1210. 1210. 0 0 cancel. Clear? 11 2s are and 11 11s are. So 8 by 11. 8 by 11 we have. So 8 by 11 means what? Simply 8 11. So 0 is 77. Again 2 22. Again here 8. So I is equals to 0.727 amperes. This is the amount of current in the circuit that should be taken by the combination of two resistors. So I think so children, in this way you have to write the solution. Very simple. If you can understand this one, like the video and subscribe to my channel and inform my channel about my channel to other friends also. I think my channel is so helpful to for them. Okay, thank you for watching.